Hashtag feed your skills. Hashtag let's learn and grow together. Hello everyone, good morning, good afternoon, and good evening. A wonderful day to all of you. Welcome to another live session of free international webinar here in the Institute of Global Professionals or IGP. My lovely audience, I am Marbet, a global member of IGP from the Philippines, and I am delighted to be your host. I'm so excited for this occasion that we can convene virtually through this international free webinar brought to us by the Institute of Global Professionals. It is my pleasure to be with you once again in this virtual event. This is another opportunity for learning and another milestone of growing for all of us. I am proud to tell you that every day many new participants are joining with us. I'd like to welcome all the new participants to IGP's global family. With this, I am compelled to give you a little background about IGP. The Institute of Global Professionals is an educational institution which provides social work. We believe that it is not effective to increase one's skill by just acquiring formal education. In accordance with our mission that is to empower people and hone their skills, we provide training and consultation to generate a proficient generation through webinars, trainings, offline and online courses with highly competitive speakers and well-trained coaches from all across the globe so that we can cater you with the best learning platform. I am proud to inform you that IGP is an ISO certified training and education institute. We are internationally recognized and globally accredited. Did you know that IGP is a multi-awarded and award-winning most engaging e-learning platform? Yes, we are. Thus, IGP is your trusted platform to learn new things from the global leading leaders. We are the leading online skill development institution with thousands of learners worldwide. Most importantly, IGP is committed to serve. IGP is bringing the community of professionals to grow together and learn from each other. Here in IGP, learning never stops. I hope that everyone will stay with us until the end of the program because we have a lot of things in store for you today. You will not just listen to our speakers here in IGP, but we appreciate your active engagement in the comments section. We encourage your participation in our live quiz competition, and also we ask for your interaction and participation in the Q&A part of the program. In our live quiz competition, the top 10 participants will receive the quiz completion certificate that is right after the live event. This will be posted few minutes after the live event in IGP's official Facebook page. Then it will be ready for you to download. After which is the Q&A part where everyone will have the chance to interact with our speaker by sending in your questions in the comment section. And also during our live show, there will be questions that will be displayed on your screen. This will keep you engaged all throughout the duration of our webinar. Simply send your idea in the comment section below. Every day during our live session, we award certificate of lifetime membership to the most active, enthusiastic, and consistent participant. So what are you waiting for? Share our live event to your friends and to your community or even in the other social media forum such as LinkedIn and Instagram. Write comments and feedback in the comment section. Who knows, you could be the next recipient of IGP's Certificate of Lifetime Membership. And please be informed that e-certificate of this webinar will be provided to all the active participants. Before the end of the program, I will give you the certification code together with the certification process on how you can generate or auto-download your e-certificate. With this, everybody is encouraged to stay with us until the end of the program. Here in IGP International Webinar, lots of exciting things awaits us today. I'm sure that all of us will have many e-takeaways and payoffs from this webinar. Only from IGP. We wish that you remain with us in this endeavor. Ladies and gentlemen, I'm proud to be associated with IGP as a global member. I'm so honored to welcome all of you to the Institute of Global Professionals Pre-International Webinar. Once again, I am Marbeth, a core volunteer of IGP from the Philippines. I'm so privileged to host today's webinar. With this, I would like to say let's watch together and learn together. We believe that the power is gained by sharing knowledge, not hoarding it. And did you know that as of this afternoon, we have already successfully completed 606 webinars in various topics of your interest? All of these are available on our website, that is www.eduigp.com. Again, that is www.eduigp.com. Feel free to access them anytime. You may also check all recorded webinars anytime on our Facebook page, Facebook group, or YouTube channel. With this, we expect that all of you are getting a little bit benefited both in your personal and professional life. From time to time, please like, share, tag your friends, and write comments. Share us how you feel about IGP and what you think about IGP. You may also share us how IGP is being helpful to you both in your personal and professional life. And also, please don't hesitate to ask questions or feedback. All of this will be greatly appreciated. Don't forget to like and subscribe and join our Facebook page, Facebook group, and YouTube channel. To those who are with us in the YouTube channel live streaming, make sure to click the bell button to be notified with our live streaming every day. And to those who have joined us in our Facebook page or Facebook group, make sure to pin IGP's Facebook FB group and FB page so that you won't miss the notifications of our live and upcoming webinars. It is my humble request for all of you to support us by spreading the news about IGP's free international webinar to your friends and to your community. Your support is greatly appreciated. Thank you, thank you, thank you so much. And before proceeding to our program, allow me to greet some of our active participants. Hello and greetings to the following people. Hello to Ma'am Evelyn Wapari. She is our early bird for today, and also together with Sir Alex Javier Alvarez. Hi to Romel S. Asuncion. And hi to Sir Joseph Nabales Placer. Hello to... Okay, just let me back read all the comments. Sheila Umapay. To Innocent Dajang. And to Carmela Haen. Hello, Sir A.K. Adhikari. Hi to Nancy Gida. Isaiah Kiangwi. Hello. And to Gemaline V. Rivera. Hi to Lara Alberto Magleo. Hi to Nancy Gida. And greetings to Diosevan Roma. Okay, thank you, Sir Joseph, for tagging your friends. Hi to Jeneline Borja. Hello to Malu Basco. And thank you also, Sir AK, for tagging your friends. Hello to El Bastri. Hi to Nancy Gida. I hope I could read all of these messages. We have so many participants today. Hello to Just Be Original. To Kenneth, John Kenneth Goyang. Hi. Hello, everyone. And even to those names that I was not able to read in this session, hello to all of you. Hi to Muhammad Arafat. Okay. Hi to Sotung Naing. Hello, everyone. I hope I could read all your names. Greetings to all the active participants of IGP's daily webinar. And Shout out to our host this afternoon and this morning. Shout out to Sir Kasi Kamrul Hossain. Again, I would like to request everyone, please share our lives event to your friends. Invite as many friends as you have to attend this session. And also, I would like to request everyone, please let us use our magic pointy. Let us click the share button together. Shall we do it at the count of three? Okay, one, two, three. All right, did you do it? Did you share our live session to your friends and to your community? Thank you so much for that. Happy learning, everyone. And also, guys, I would like to tell you, please utilize the comment box for your questions. The CSR team and the IGP facilitating officers will be happy to answer all your queries. So, without further ado, let's start the program with the IGP's mantra: Feed your skills, innovate, inspire, impact. For today, we are presenting webinar number 607 on prerequisites to hypothesis testing in statistics. Indeed, we are privileged to have with us today a very competitive and reliable speaker from the Philippines. Currently, he is a Master Teacher 3 at Benigno S. Aquino National High School in the province of Tarlac, Department of Education, Philippines. Ladies and gentlemen, let's give a warm welcome to our keynote speaker, none other than John Patrick D. Serrano from the Philippines. Let's welcome him with virtual round of applause. Hello, Sir
Thank you
John
so
Patrick.
Hello po,
How are you
Ma'am
doing?
Maribeth. Thank you so much, Ma'am Maribeth, for the warm introduction and for the warm welcome. Thank you to the IGP. Greetings of love and peace to everybody. At this point, I am already sharing with you my slides, and I hope I am heard loud and clear. At
Yes,
this
you are,
juncture,
sir.
thank you so much
And
po. At this juncture, let us talk about the prerequisites to hypothesis testing in statistics. I am Sir Patrick, your sharer for this afternoon, for this evening. At this point, I would like to have this image not as an expert in the field. We'll try not to speak through the language of a statistician, but instead, uh, as a communicator, wherein we're not going to utilize the language of a statistician, but instead, we would try to transcend the topics, essential topics in statistics, in a way that is understood by the general public. I am a master teacher too from Benigno S. Aquino National High School, Department of Education. I have been in public service through the Department of Education for 6 years now. I am happy to be with you, po, and allow me to share something about statistics. So basically, statistics is this field of math that deals with the collection, presentation, analysis, and the interpretation of data. But before we proceed further, profound thanks to Dr. Nestor P. Nuesca, the supervisor in mathematics of the Department of Education Region 3, to Dr. Nelia Y. Andres, the principal for at Benigno S. Aquino National High School, and to Sir Redentor B. Tabamo, uh, the head teacher 6 and OIC assistant principal at Benigno S. Aquino National High School for opening the door of IGP to me. At this point, when we talk about assumptions, let us have this scenario wherein as if we are dealing with students regarding their test results, and we would try to test whether the number of hours in studying, the number of hours studying is a predictor of their test results. Naturally, if we are amateur researchers, uh, we just tend to test the number of hours as predictor of test results right away. Specifically, if we already have the data for the number of hours studying and the data for the test results right away, we could just hit our SPSS, or we could just hit whatever statistical software or program that we have and could run the appropriate correlational statistical procedure for that right away. And we could come up with a certain numerical value and come up with a certain statistical procedure. But here's the catch. Although we could just hit our statistical program, what if we are going to categorize this number of hours studying as our predictive variable, assuming that we are going to classify it or dissect it into two major groups, wherein the first group would involve students who have long number of hours studying, and the other group would be the students who have minimal or less number of hours studying, assuming that based on our initial observation, these students who study long number of hours of studying would result to higher test result, assuming that that is the first pre-result that we would have. On the other hand, when we compare the results of these students who belong to those who have fewer number of hours studying, what if it, it is shown that some of them have high test results, some of them have lower test results? So the question is this. So if that is the case, as we regroup this number of participants based on the number of hours studying, the question is now number of hours studying a good predictor already of test results? Definitely, it's not, because as soon as we have completed our data, it is not right. It is not right that we compare them right away. First thing first, we have to determine if they are comparative in the first place. So before comparing our variables, before comparing our groups right away, it is essential in statistics that we have to test first whether there are comparative in the first place or not. And we call that testing before the actual hypothesis testing as our assumption test. For every statistical procedures lies a list of assumption tests. This assumption test should be met first before testing our hypothesis. And we actually have a wide variety of statistical procedures ranging from the most common, such as the Pearson R, Spearman-Monroe, analysis of variance, and so on and so forth. These statistical treatments have assumption tests. And before proceeding to these statistical treatments, these assumption tests should be met first. And that is the focus of our discussion for this afternoon or for this evening. So, at a glance, here's the bird's eye view of what is expected to be discussed in this entire discussion. So, we'll talk about in passing sound measurement, center data, collinearity, unidimensionality, normality, multivariate normality, outliers, homogeneity of variances, homoscedasticity, linearity, data independence, randomness, and additivity. As you can see, this is not actually the be all and end all of statistical assumptions. We also have others such as sphericity and so on and so forth. However, I have only included in my slides some of the most commonly required statistical assumptions for most commonly utilized statistical treatments. As you can see, while the pronunciation of some of these are quite unfamiliar so as to their level or to their nature, they are quite not easy to understand in the first place. But as I have mentioned to everybody in the beginning of this presentation, we'll try to speak not on the foot of a statistician expert, but on the foot of a communicator. So we're going to try to simplify the nature of the statistical assumptions to you. uh, I would like to reiterate to everybody that this is not an advanced discussion. We're only going to talk about the bird's eye view of some of these statistical assumptions. We're not going to show computations as such, particularly that we only have limited time allotments for this. So without much ado, let's talk about sound measurement as one of the statistical assumptions. But before I proceed, Napo, these are the statistical assumptions. For some of these are requirements, some of these, but not everything, are prerequisites for certain statistical procedures. So it is essential that we would be familiarized with these various statistical assumptions, such that when we are ready to choose our statistical treatment, we are already familiarized with these various statistical assumptions. Ano po? So for sound measurement, it is essential that we should first establish descriptive statistics, which is actually essential or even required in most of our statistical procedures actually. When we talk about descriptive statistics, we are assuming that scores are free from coding errors, So whatever has been collected through our data gathering procedure must be correctly coded in our statistical programs. Aside from that, uh, there are cases wherein when we gather data from our participants, assuming that we are using uh, skill-based instrument. When we say skill-based instrument, we have this question, and our participant is going to reflect his or her reflection response in a scale of five. Say, for example, 5, 4, 3, 2, 1, 3, 2, 1, or for dichotomous responses, 2, 1, or any two responses. Aside from the free, we are expecting freedom from coding errors. There are also cases wherein we have this set of statements in a skill-based instrument, and there are one or two items which were omitted to be answered, say, for example, by our participant. So there are missing values. There are cases, this happens in real life situations, when there are missing values during our data gathering procedure, we are not anymore going to include all other responses of that particular participant. Meaning to say, when a participant uh, returns to us a certain instrument which has been incompletely taken, the entire responses of that particular participant will be omitted from our statistical procedure. And that is still part of what we call as data cleaning. Data cleaning, meaning to say, before we proceed to our actual statistical procedure, as we encode our our data, first thing first, we make sure that we are free from coding errors, that what has been collected are truly and correctly coded, omitting participants with the incomplete responses to our instrument, and removing outliers. There are no out of bounds entries beyond the expected range. So in case that there are outliers in our collected data, when we see outliers, these are extremely high or extremely low scores from our collected data. We are supposed to remove those outliers because tendency, there are statistical instruments that are super sensitive to these outliers. They could actually affect the results of a phenomena which we do not want in our statistical computations. That is why we are removing these outliers. So how are we going to determine whether some scores are outliers or not? We're going to discuss that further as we proceed with our discussion. We also have to avoid attenuation. When we say attenuation, it pertains to the artificial reduction of data leading to underestimation of the effect size of a variable. So, what do we mean when we say artificial reduction of data, which is called attenuation? I would like to present to you this table. I would like to show my laser pointer. Okay. So we have here person correlation between and among age of respondent, highest year of school completed, and income. The actual the actual numerical data as age, highest year of school completed, and income. So if we are going to compare them right away based on their raw scores, will have these results from this first red box. So, say for example, in this pink cell, the correlation between the age of the respondents, and the highest year of school completed is negative 1.75 and so on and so forth. Gives us a significance level of 0.000 and so on and so forth. However, there are cases where we call as attenuation that instead of encoding or computing these variables based on their raw scores, we group them into categories. We call that grouping of raw scores to group variables as attenuation. In this case, the age of respondents from the raw scores have been grouped have been attenuated by three groups: old, medium, and young. And there is an interval for the age for the old group. There is an age interval for the middle age group, and there is an age interval for young group. So after reducing the data artificially, which we call as attenuation, that's the time that they have performed the statistical treatment. So in this case, if we are going to compare the results are already far from the original results. In this case, if we are going to compare results from the pink cell here, which are attenuated, and the actual results here, pink, from negative 0.175, it went to negative 0.096. Numerically, it's far already. It's far. So in this case, for income, each of respondent and income using the raw scores, the computed Pearson R is negative 0.44. When attenuation has been conducted, it became negative zero point zero 0.018. Very far already from a negative 0.044 to negative zero point zero 0.018. Different. It's the results are far already. That is why while there are practices in the research world where they conduct attenuation in their scores before they run the statistical treatment, you should avoid that. Apo. You should avoid that. You should avoid attenuation because it will lead to results that are far reflective already of the phenomena being studied. Okay? So we're not supporting attenuation. Another thing is to avoid tautological correlation. When we say tautological correlation, we are actually correlating variables which are essentially just the same. Say, for example, the first variable is awareness and the other variable is knowledge. Is there a way that you are aware and yet you do not have knowledge about it? No, there's no such thing as that. Or is it possible that you are not aware of it? You're not aware of it, but you have knowledge about that. Is that possible? No, because when we collect data, awareness is logically just the same and as just essential by essence as knowledge. So we should avoid those things. We call those as tautological correlation. That tautological correlation is committed when we compare variables which are essentially the same in the first place. Okay. Cell size adequacy. This cell size adequacy is utilized when we are talking about cross tabulation. Say, for example, in this case where we are using chi-square test, cross tabulation for chi-square test. Um, the rule of thumb is 80% of the factor space should be greater than 5. So what do we mean when we say factor space? These are the cells these are the cells where we put in our counted frequencies. So for example, how many among the this is appropriate for scores that are gathered by head count. They are countable. You can head count the number of females who have not graduated yet. You can count the number of females who are in college. So you gather data by head count. So this is possible when you gather data by head count. So here is our factor space. We have 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 factor spaces. The rule of thumb for the cell size adequacy is 80% of these factor spaces should have scores greater than 5. So 1, 2, 4, 8. So the 80% of 8 cells is 8 times 8, 64. Tama ba? One, one. So, not more than one among these factor space should have 5 or below. In this case, we do not have a problem in that case because all scores in every factor space have responses that are 6 or more or greater than 5. All right. So why is it critical that when we deal with cross tabulation, it should be 6 or above, or it should be greater than 5? Why? Because we are dealing with variables. Because we are dealing with variables. If you only have five scores in one factor space, that value is not varied enough. And when your scores are not varied enough, your computations will not be truthful. In case of statistics, you are not allowed to conduct or to continue with your computation should there be any point that you have computed more than 20% of your factor spaces having scores 5 or less. All right, that's still part of sound measurement. For data requirements, there are actually statistical procedures that are sensitive to the level of requirement or the level of measurement that you should have in your data. Say, for example, uh, for Spearman rule, the measure of the level of measurement should be ordinal. Should be ordinal for Spearman rule. On the other hand, for person R, it's not anymore ordinal. It should be interval or ratio. This is essential because there are statistical treatments that are sensitive to the level of measurement that your data should have. There are statistical data that are limited only to nominal variables. Okay, so let us study this. When we say when we say nominal variables named by nature, we are named variables that are named by nature, categorical by nature. But the thing is, nominal data are part of the lowest in the hierarchy of the levels of measurement. Meaning to say, if you are running a statistical treatment wherein the level of measurement is only nominal by nature, it only means that your statistical treatment is weak. Your statistical treatment is weak. Should you have any point that you could move your level of measurement into higher levels, such as the ordinal or the interval or the ratio, you are increasing the level of validity or correctness of your statistical or the strength of your statistical computations. So for all statistical computations that are requiring nominal data by nature, since they are only categorical or grouping by nature, these are considered as weak statistical treatment. Why? Because if you have if you have categories, you cannot identify which among these categories are better than the other. Let me give an example. Assuming that in your categorical data collection, you would want to determine the the religion of your participants. So based on that data collection, it was determined that the religion are Iglesia ni Cristo, Roman Catholic, born again, and so on and so forth. But the question is, which among these religions are better than the other? The nominal data cannot tell that because we're only uh, we are only getting names, we're only getting groups, but there is no measure which among these are higher or better than the others. So there's no sensitivity to measurement. There is no sensitivity to measurement if the level of measurement of your variables are only on the nominal level. And that is the reason why statistical treatments that require nominal data are weak by nature. If you're conducting master's thesis or doctorate dissertation and your statistical treatment only involves purely nominal data, that is weak. Because we cannot identify the extent of relationships, if, for example, or the extent of difference, if, for example. We cannot measure that extent that much if you're only dealing with nominal data. On the other hand, the higher level of measurement is ordinal. Ordinal. We are ranking already by a certain order, which is first, the best, which is second, the next best, which is the third, next best, and so on and so forth. So, aside that we have already identified them by group or by category, we are now aware which is better than the other. We can already identify which among them are better than the other. However, this is still weak. Why? We already know which is better than the other because they are ranked already in a certain order. But we do not know yet but we do not know yet how much a certain group is better than the other. We only know that one group is better than the other, but we do not know yet how much that group is better than the other, or to what extent that group is better than the next best. That is why, if there is one researcher telling to you a certain phenomenon that uses Spearman, which only uses ordinal data, and another researcher who uses Pearson that uses interval or ratio, you should believe. that researcher who uses interval or ratio, who uses Pearson, because Pearson is a stronger statistical procedure compared to the Spearman. Why? That is because of the data level or the level of measurement required in that statistical treatment. Okay? That is why if we want to publish our research paper and would want it to be competent by nature, we should focus on variables which are gathered or measured using higher level of measurements. To which are in the interval level or in the ratio level. The difference between the interval and the ratio level already have numerical equivalencies of the extent or how much that particular group performed. The difference between the interval level and the or the ratio level is the occurrence of the absolute zero or the sensible zero. When we the interval do not have absolute zero or the sensible zero. Or while on the other hand, when we say ratio, when with the measure, when the data are in ratio category, there is this absolute zero or sensible zero. Meaning to say, when we say absolute zero, when we say zero, it's nothing. When we say zero, it means nothing. Why? Are there cases wherein when we say zero, there is still there? Yes, there are cases. Say for example, temperature. When we define temperature, we are talking about the amount of heat in that certain matter, and that heat in that certain matter is called temperature. However, when we say what if the temperature is 0 degrees Celsius, that number is zero. Does it mean that there is already no amount of heat in that matter? Wrong. There is still heat, there is still heat in that matter, even if it is portrayed as 0 degrees Celsius. So, zero is not absolute or zero is not sensible. That is why temperature is only categorized as interval. On the other hand, when zero is absolute or zero is sensible, when we say zero, there is really inexistence in that kind of data. Meaning to say, uh, enrollment, enrollment, say for example, the number of enrollees. If there are no enrollees, 0 enrollees in that particular class, does it mean that it is possible that there are people in that class or there are students in that class, considering that there are 0 enrollees? There's no such thing as that because that zero number, 0 enrollees, number of enrollees is absolute, is sensible. There is non-existence in that zero value. So the highest level of measurement is zero. The more that we go through ratio level in our measurement, the higher the level of statistical treatment that we have. And statistical treatments are usually sensitive to these levels of measurement. Okay, let's proceed to the next slide. But I think the slide hangs. Okay. So let's talk about now the centered data. When we say centered data, the mean is subtracted from the predictor variable. Why should we subtract the mean from the predictor variable? And and when should we need to do this? Why? Because we need to reduce multicollinearity. Multicollinearity. So whenever you have your data, whenever you have your data and you have tested your assumption, you have run your assumption test, and based on your assumption test, there is multicollinearity, which we do not want. We do not want multicollinearity. So to correct your data, we need to utilize centered data. And we could utilize centered data by subtracting the mean by subtracting the mean from every score in that predictor variable. But what is multicollinearity in the first place? And when could we commit multicollinearity? We do not want multicollinearity. Ano? So when we say multicollinearity, it is a statistical concept where several predictor variables. When we say predictor variables, we are pertaining to our independent variables. There are several predictor variables in a model that are correlated. So what do we mean by that? So it is observed when intercorrelation among predictor variables hit 0.80 coefficient. Example is, wait and wait, we will return to that. So let me illustrate to you multicollinearity. Multicollinearity. So for example, I have here on the picture, we call that person as Elmer. We call that person as Elmer, say for example. According to Elmer, when he watches the television, he becomes happy. So watching TV brings him happiness. On the other hand, he also mentioned that eating snacks such as popcorn gives happiness to him as well. So assuming that in your research you could measure happiness, say for example, as your dependent variable, and you could measure the number of hours of watching, and you can measure the amount of snacks eaten by Elmer. So for example, all these variables, your independent variable, eating snacks and watching TV, assuming that you could measure them, and at the same time that you could measure happiness, your objective is to determine whether your predictor variables, independent variables, watching TV and eating snacks, are true predictors of happiness. So, assuming that during your assumption test, it was revealed that watching TV leads to watching TV gives happiness to Elmer, and at the same time, eating snacks provide happiness to Elmer. That is not right. That is not right because in testing, uh, in testing predictor variable to its dependent variable, there should only be there should only be one predictor variable, or there should only be one independent variable that causes change to our dependent variable. So what makes it multicollinearity? So assuming that watching TV causes happiness, and at the same time, eating popcorn causes happiness. Multicollinearity happens when we compare data for eating snacks and watching TV. When we compare those two predictor variables, would result to a correlation that is 0.80 and above. That's the time that you could tell that your data is multicollinear by nature. So if that's the case, when you have data that has multicollinearity, it's either you cannot proceed with your statistical procedure, or you only choose one one predictive variable that you will test whether it truly affects your dependent variable or not. It's either you do not compare them at all, the independent variable being a predictor variable, or you just choose which one of those two independent variables will you test as predictor variable to your dependent variable. So that is multicollinearity. Or in case that you have in case that you have multicollinearity and you would want to proceed and would like to preserve those two variables, those two predictor variables, might as well you could have this corrective formula. You're going to transform your data in a way, your predictor variables, you're going to transform them in a way so as not to commit or reduce the possibility of having multicollinearity, and how we're going to transform your multicollinear variable by centered data. And how do you do centered data? You subtract mean from every score in your predictor variables. Okay, so here's a perfect example, an example of a perfect multicollinearity. For example, weight in pounds of, of that matter, and then the other variable is weight in kilograms of that same matter. They only differ with the unit of measurement, but sure enough, those variables are predictors of that particular dependent variable. And when you compare them, and when you compare those two predictor variables, sure enough that they will result to 100% correlational coefficient, which is an obvious example of multicollinearity. We also have what we call as unidimensionality. When we say unidimensionality, we are talking about that tool or that way where we could measure a certain phenomena or a certain variable. Unidimensionality tells us that for every tool, one tool can only measure one variable. Can only measure one variable. If there is one tool if there is one tool that can measure two or more variable, that is not nice. There is no unidimensionality in that instrument, and that is not nice. Why? Because if your instrument does not have unidimensionality, uh, the reliability level is low. The reliability level is low. That is why to make sure that to measure unidimensionality that results to higher reliability, we have such tests to conduct. It could be we could use Cronbach alpha. When we say Cronbach alpha, the individual items are correlated with one another. So each statement is correlated with one another, and then as a whole, we determine the correlation. So we call that coefficient as the Cronbach alpha. We could also measure unidimensionality. So if the resulting Cronbach alpha is zero point 0.8 or better, that is highly reliable. If it is zero point 0.7 or higher, that is still acceptable for a research endeavor. Highly reliable, still unidimensionality has been achieved in that case. We can prove that by using Cronbach alpha. Another is by using factor analysis, confirmatory factor analysis, and Gatman scaling. However, we're not anymore going to dig into those things. I am just telling this in passing to you. So let's talk about normality. Usually, when we say, actually, normality is an assumption that is required by many statistical treatments that are commonly used in social sciences, particularly in the conduct of educational research. So if a particular statistical treatment requires normality, we should determine first whether our data are normal by nature. What if you are comparing two groups? What if you're comparing two groups? The first group is normal. The distribution is normal, and the other group is not normal. Can you compare them again? Assuming that we have two variables, two groups that you would want to compare, by testing the normality before you actually compare them, because we are talking with assumption test that you conduct before the actual hypothesis testing. So assuming that you're comparing two groups, the first group is normal, the other group is not normal, because basically it's either it's highly skewed or the kurtosis is high or low. The first group is normal, the other group is not normal. Can you compare those two groups? No. We cannot compare them. That is why it is essential that when we compare groups, we test first normality. That both groups should be normal by nature. And how are we going to know whether a certain distribution is normal or not? We have to compute by descriptive statistics the kurtosis and the skewness of those groups. It will be categorized normal. The distribution of a group is considered normal if both the kurtosis and the skewness are both within the range positive, negative 2. Positive, negative 2. Graphically, the graph of a normal curve looks like a bell-shaped curve. I believe that we have already seen that many, many times during our college or master's days. So I believe that you know that already, that that normal distribution. Let's talk about how we would know whether a certain distribution is normal or not. So the kurtosis and the skewness should be both positive, negative 2 range. From positive 2 to negative 2, both kurtosis and the skewness. So what if one of those do not lie within that interval? So let's talk about skewness first. We have that left skewed or negative skewed. We need to say the majority of the average groups, the average group lies the higher value, higher frequency. So in this case, if you're talking about scores for a left skewed distribution, many of our students got high scores. In this case, right skewed or positively skewed, meaning to say many of our respondents got low scores. Between left skewed or negative skewness and right skewed or positive skewness, what is more common in the conduct of research is the occurrence of right skewed or positive skewness compared to the other. This rarely occurs. Ano? When we say skewness, we are pertaining about the tails in the first place. So this is left skewed because the tail is on the left side. This is right skewed because the tail is on the right side. Okay? So what if the first date, so I have mentioned here, assuming that we're comparing two groups, the first group is normal and the other is not normal. And the other is not normal. You cannot compare the two. You cannot compare the two. So you can only compare two groups if they are both normal. So if the other group is not normal, you have to determine if the skewness is skewed to the right or skewed to the left. So assuming that your distribution is skewed to the left, is skewed to the right. So for example, in this case, if it is skewed to the right, so uh, you perform inverse transformation. You involve, you conduct inverse transformation so that the right skewed distribution will be converted into its normal distribution form. On the other hand, if your data is left skewed or negative skewed, um, if it is negative skewed, uh, to correct it or to make it normal, you subtract all values from the highest value plus 1, and then that's the time that you apply inverse transformation. Inverse transformation. These are corrective transformations so that skewed distribution are converted into normal distribution. So if you can see this right skewness, in this right skewness, you perform inverse transformation right away. On the other hand, when we deal with left skewness, we first tend to subtract all values from the highest value plus 1, and then that's the only time that we utilize inverse transformation. Why is that so? Why is that so? Because when we deal with left skewness, there is no way that we could convert left skewness to normal distribution right away. There is no way that we could convert left skewness to normal distribution right away. The procedure is from left skewness, we convert it first to right skewness, and that's the time that we utilize inverse transformation to convert it into normal distribution. And the way of converting left skewness to right skewness is done by subtracting all values from the highest value plus 1. Are you happy? So how would we know if it is skewed? So remember, this is skewness, positive 2, negative 2. So if your skewness is negative 2 or less, negative 2 or less, it's negatively skewed. On the other hand, the computed skewness is positive 2 and above, it's positively skewed. On the other hand, when we say kurtosis, we are pertaining to how flat or how tall our distribution is. When we say there's no problem regarding its skewness, if for example, but there is concern about the distribution of our data. If it is too tall, we call it leptokurtic. When we say leptokurtic, many of our participants lie between the average interval, and almost none or very minimal among our cases lie between the extremes. So if that's the case, we have leptokurtic distribution. On the other hand, when we say platykurtic, this tells us that many cases lie between the tails or lie between the, the extremes. That is why, if you can see, the graph for platykurtic distribution is slightly elevated compared to the graph of a leptokurtic and a normal distribution, because it tells us that there are more cases on the extreme side of our distribution for a platykurtic distribution. This is usually associated by a value of value of our uh, kurtosis. Usually negative 2 or less, we are safe that we are computing a platykurtic distribution already. Perfect 0, normal. Positive 2 or higher, leptokurtic. We are sure that we are having uh, a, a leptokurtic distribution. In this case, talking about the kurtosis, the highness or the lowness of our distribution, what we want is a normal distribution. And that's what we should establish before we compare our variables right away. Labs 5% na lang to. Pwede pa check. Kailan ko lang. So how would you know, or aside from determining the skewness and the kurtosis by descriptive statistics, whether your distribution is normal or not, we also use Shapiro-Wilks W test, all the Kolmogorov-Smirnov test to determine whether our groups are normal or not. So in this case, we have a sample table for computing the Kolmogorov, Smirnov, and the Shapiro test. So we're going to look at our p-value. It is normal. It is normal when the p-value is greater than the alpha level. So if your alpha level is 0.05, the distributions are normal if the computed p-value for your Kolmogorov Smirnov is 0.05 or higher. The same is true with using the Shapiro wheel. So if the alpha level is 0.05, a p-value, a computed charge, charge. Oo. So if it is greater than 0.05, it's normal. It's normal. Ano? However, Shapiro width is utilized when the number of cases is less than 2,000. O no, Shapiro width is appropriate when the number of cases is less than 2,000 only, 2,000 or less. However, when you exceeded the 2,000 demarcation line, that's the time that the utilization of the Kolmogorov Smirnov is appropriate. Okay? So, talking about outliers, we have also talked about during our first slides that we should remove outliers because there are statistical treatments that are actually sensitive to these outliers. Wala bang ano, wala bang extension. Lang tayo saksakan. Okay. So we should remove these outliers. However, how would you know whether you are having outliers or not? Ayun. Ang galing. Thank you. So how would you know whether a certain score is an outlier or not? Charge on. So first thing first, your individual score should be converted into their z scores. Your individual raw scores should be converted into their z scores. All raw scores having z scores more than positive or negative 1.96 are considered outliers at 95% confidence level. Right? So that's the way to determine our outliers. So all raw scores having z scores beyond or higher than positive negative 1.96 should be removed before running your actual computation. You see that assumption test is not easy. Assumption test is not easy because assumption test tells us that before actually running your statistical treatment, there are a lot, there are a bunch of things that you should do first. You should clean your data before they are ready for actual computation, statistical computation. So we also have what we call as the homogeneity of variance. So it is also aside that two variables should be normal before comparing them. It is also essential that that two groups should have homogeneity of variance. We need to say the variance of these groups that you are comparing should be equal or the same. So if the variance of one group is technically not the same or far from the variance of the other, there's no way that you could compare them. There's no way that you could proceed with your test of difference, whatever test of difference is that. So to test whether the groups that you're comparing has homogeneity of variance, it's either we use the Leibniz test, or the Brown and Forsyth test. However, the Leibniz test is used when the number of cases for every group are equal or close to being equal. So for example, the first group has 45 cases and the second group has 45 cases or 46 cases or 44 cases as long as it is close to 45 cases. To test homogeneity of variances, you should use the Leibniz test. On the other hand, if the two groups that you are comparing are not equal or are far from another, so for example, the first group has 45 cases and the other has 60, say for example, 45 and 60 are different, are far from one another. So to test whether variances are homogeneous between these two groups, it is appropriate to use the Brown and Forsyth test. Okay? Now, when we talk about analysis of variance, when we say analysis of variance, one way analysis of variance, meaning to say we are comparing three or more groups. Part of assumption test for analysis of variance is that each group should have homogeneity of variance. Meaning to say, the variance of the first group should be essentially the same, statistically the same as the second, essentially the same as the other. So what if there is a case that homogeneity of variance is not met, meaning to say you cannot use analysis of variance. You cannot use analysis of variance. So if you cannot use analysis of variance, what you're going to utilize is the Welsh test. That Welsh test is going to tell us the differences among these two groups when we cannot assume the homogeneity of the variances among these three or more groups. We cannot use analysis of variance because it is assumed that there's no homogeneity of variance, but we can still proceed with testing the differences among these three or more groups by using Welsh test. Okay, let's talk about homoscedasticity. So that homoscedasticity, uh, the variance, the variance of a certain distribution should be uniform. When we say uh, should be uniform, what do I mean by this? So, assuming that there are two groups, in this case, the two variables that we are testing are the number of R's as our predictor variable or our independent variable, and the other variable as our test results that I have mentioned already in the introductory part of our discussion. So, what we're going to do is for our predictor variable, number of hours of study A, we're going to group number of hours. Could be possible that we could group them into two or could group them into three. But in my case, I would like to just group them into two. So groups of students who study long number of hours and students who study few number of hours or less number of hours. I will just have to indicate in my paper the interval for large number of hours, long number of hours, and short number of hours. The variance, the variance of data for students who have a long number of hours should have consistent variance with those students who have a short number of hours. Meaning to say, the variance for the long number of hours, the variance of data for the long number of hours should have consistent or near the same variance as the number of hours that are less. That is homoscedasticity. The variance among subcategories in a particular variable should be uniform. That homoscedasticity is uniformity of variance within that variable, which is different with the homogeneity of variance. When we say homogeneity of variance, we are testing a certain variance of a certain group compared to the other group, which should be homogeneous or close or almost the same. Group among groups. On the other hand, when we say homoscedasticity on a certain variable, when we cut or when you regroup that one variable, the variance should be consistent to all those subgroupings. Okay. So if the variance among those subgrouping in that particular uh, variable is almost the same, if the variance is almost the same, that's the time that you have achieved homoscedasticity. What if you have variable, regardless whether it is your independent variable or your dependent variable, you have one among your variables which is not which do not possess the property of homoscedasticity. You cannot proceed to your hypothesis testing if that's the case. If what you have computed is heteroscedasticity, statisticity, you cannot proceed with your hypothesis testing. This is very critical. Hemoscedasticity is critical. We also have what we call as the linearity. Tendency is when we compare groups or variables, what's the possibility of the likelihood of being compared with one another? That's what we that's what we mean when we say linearity. And that linearity could be tested by using graphical methods, curve fitting with R squared difference test, analysis of variance test of linearity, eta correlation ratio. That eta correlation ratio is compared to your Pearson R such that if that eta correlation is equal to the Pearson R, there is linearity. On the other hand, when the computed eta correlation is greater than the Pearson correlation, linearity is not achieved. So if linearity is not achieved, you cannot compare those variables. And Ramsey reset test. So we're not going to dig into those anymore. I'm only telling this in passing. Data independence. One observation is not influenced by the other because there are cases that we repeat our observation of the same group. Example, pre-test, post-test. Pre-test, post-test. The activities in the pre-test should in no way affect the behavior in your post-test. That is why, huh? That is why, whenever we talk about data independence, in as much as possible, the content of your pre-test should not be the same content as your post-test because there is this concept that students tend to have higher scores in the post test not because their performance has been improved, but only because they got familiarized already with the content of the pre-test. So whenever we talk about data independence, we reduce the possibility of administering the same exact content between the pre-test and the post-test. So what is suggested? You prepare two tests, pre-test and the post-test. However, you should compare the level of difficulty, the content as the same. Okay, so as the same. It's either you use the parallel method and so on and so forth, the test retest method. There are lots of ways on how we validate our instruments, which is not anymore a part of our discussion this evening. So bottom line is data independence. When we repeat measures of data, for every measurement of data should not be affected by the other or should be influenced by other activities. Randomness. So randomness should be observed as well. There are actually a lot of ways on how to measure randomness. Could be runs test, sign test, the most common of those. Meaning, what this tells us the randomization of our scores. Because if you're dealing with uh, if we are dealing with research data collection, tendency is if our collected data are 3, 3, 3, 4, 4, 4, 5, 5, 5, 6, 6, 6, there is pattern. The scores of my students are 1, 2, 3, 4, 5, 6, 7, 8, 9. Who will believe you? Who will believe you? Obvious, fabricated, those are obviously fabricated results. If results are not random by nature, or your scores follow a certain pattern. So to test that your scores are truthful by nature, one of the ways to determine whether your gathered data are truthful, results are of actual data collection, not results of fabrication, you use test of randomness. Runs test, sign test, the easiest among the others. But there are a lot of other randomness tests. And then additivity, that the effect of one independent variable or predictor variable do not depend on other independent variable. That makes it independent in the first place. So the example of this to test non-additivity is the case test of non-additivity. I believe that we are done already with our discussion. Quite few reminders only by the time that we ask our questions. Few reminders that in this platform we do not have statistician-client relationship as of now. So meaning to say, should there be any point that the nature of your question is about your research or is about a certain research, a certain SOP, statement as a problem that you would want to ask about the assumption test or the proper statistical treatment, we cannot answer those questions because at this point there is no statistician client relationship as of now. The same and true with lawyers. If there is no lawyer client relationship, definitely we cannot answer those specific questions because there are a lot of things that we should consider before arriving at a certain statistical treatment. So a statistician needs to look for other cues before arriving at a certain statistical treatment. So should there be any point that your question is about a specific research, about the statistical part of a certain or particular research or your own research, we cannot answer those questions. Another thing is questions that are not mentioned in this discussion or questions that are too advanced compared to the content of this presentation may be better consulted privately or should be any point that you would want to establish statistician client relationship with me, you are welcome po to give me a private message through my Facebook account, Patser. It is actually reflected in the lower right corner of our slide. And po, so should you want to establish statistician-client relationship with me, I am open with those. Or should you have an advanced level of questions, statistics in mind that you would want to be clarified to me, you could consult it privately to me through my messenger. Another thing is this is not an advanced presentation because I am considering that our audience while we are all academicians, are not particularly experts in the field, which is statistics. So we are stepping on the image of a communicator, which is a public speaker with everybody and not as expert statistician who speaks the language of an expert. Thank you so much.
That was really a jam pack of useful and interesting information. A very well organized and significant presentation, sir. Thank you for your insightful sharing of knowledge about prerequisites to hypothesis testing and statistics. The knowledge you have imparted will be useful to all our audience because you shared lots of interesting ideas tonight. Thank you so much, Sir John Patrick. For the meantime, we are going to hold you at the backstage as we are holding our quiz competition. You will be back in the Q&A part of the program. All right, sir? Okay, we'll see you later in the Q&A part. Thank you so much. Before moving to our quiz competition, my dear audience, let me remind you again, don't forget to like and share this event, tag your friends in the comment box. Remember that your attachment encourages us to do better to provide you with our best service. Later, we will give you the certification link together with the certification process. And also, the certification link will be provided in the comment box. If you encounter any problem collecting your e-certificate, you may go directly in our website that is www.eduigp.com. Again, that is www.eduigp.com. Then after collecting your e-certificate, don't forget to celebrate with IGP through your check-in. At this juncture, we will now proceed to the most exciting part of this event, the live quiz competition. Afterwards is the Q&A part. I would like to encourage everyone to join our live quiz competition. There are three ways of joining our quiz competition. First, you may click the joining link in the comment section, or you may just scan the QR code that will be shown on your screen to quickly join the quiz competition, or using your browser, go to www.slido.com. Remember, our code for today is IGP. Okay, please everyone join our quiz competition. This will be fun. And also, I'd like to remind everyone that as you join in our quiz competition at slido.com, please register the name that you wanted to appear in your certificate. Okay, our code for today is IGP. Be reminded that the certificate of top 10 winners will be posted on IGP's official Facebook page. That is Institute of Global Professionals. We have already 33 participants who have joined our live quiz competition. Okay, come on, guys. You still have a minute to join our quiz competition. We have now 40 users who have already joined in our quiz competition. Okay, question number one. What factors is changed when testing a hypothesis? Is it controlled variables or independent variables? The correct answer is independent variable. Only 24% of the participants were able to get it correctly. Jeffrey A. Salem is leading our board, followed by Jenaline Borhamandawe. Next is Hazel Singalibo, followed by Elvina Montalvo. And then on the fifth, we have Janelle Lor Mandawe. Question number two. Hypotheses are made using blank reasoning. Is it theory or deductive? Okay, the correct answer is deductive. 67% of the participants were able to get the correct answer. On our leaderboard, Jeffrey A. Salem is still leading, followed by Elvina Montalvo. Next is Hazel Sangalivo, and then Evelyn Waperi. On the fifth, we have Charmaine Bernasor. Question number three. What is the ability of hypothesis to be proven false? Is it falsibility or probability? Okay, 66% of the participants were able to get the correct answer, that is falsifiability. Still, we have Jeffrey A. Salem on our leaderboard, followed by Evelyn Wapari. On the third, we have Charmaine Bernasor. And then on the fourth, we have Ambassador Joseph Placer. And then on the fifth, we have Melinda Civil Hispano. Next question. In order for a hypothesis to be considered falsifiable, it, it should be capable of being disapproved, or it should be determined causality between two variables. Causality. 65% of the participants were able to get the correct answer. It should be capable of being disapproved. That is the correct answer. And on our leaderboard, this time we have Charmaine Bernasar, followed by Emily Refugio. Next is Alex Javier Alvarez, then Jeffrey A. Salem. On the fifth, we have Joseph Placer. Question number 5. What type of reasoning is used to make a hypothesis? Is it inductive reasoning or deductive reasoning? The correct answer is deductive reasoning. 57% of the participants were able to get the correct answer. On our leaderboard, we have Charmaine Bernazar, followed by Jeffrey A. Salam. Next is Alex Javier Alvarez. On the fourth, we have Ambassador Sergeant Joseph Lazar. And then on the fifth, we have Joel A. Bernazar. Question number 6. What is a model of design used for testing? Is it prototype or diorama? 86% of the participants answered prototype, and that is the correct answer. On our leaderboard, we have Charmaine Bernazar, followed by Alex Javier Alvarez. On the third, we have Jeffrey A. Salam. Next is Jamalyn Rivera, and then Joel Bernazar. Question number 7. What are the two prerequisites to remedy the issue of studying something that is intangible, like gravity and mind? Is it hypothesis and instrumentation, or behavior and instrumentation? The correct answer is behavior and instrumentation. Only 28% of the participants were able to get it correctly. And then on our leaderboard, we have Jeffrey A. Salam. Next is Ambassador Sergeant Joseph N. Placer. Next is Charmaine Bernazar. And then on the fourth, we have Alex Javier Alvarez. On the fifth, we have Jamalyn Rivera. Question number 8. A student is testing if more men or women graduate from high school. He got his evidence from his favorite news site. This is high reliability or confirmed bias. The correct answer is confirmation bias. Only 40% of the participants were able to get the correct answer. And then on our leaderboard, we have Jeffrey A. Salem, followed by Charmaine Bernasor, and then Ambassador Sergeant Joseph Placer. Next is Abbott de la Cruz, and then Alex Javier Alvarez. Question number 9. The Whorfian hypothesis postulates people are built for language, or you can't think about things you don't have words for. The correct answer is you can't think about things you don't have words for. 52% of the participants were able to get the correct answer. On our leaderboard, we have Jeffrey A. Salam, followed by Charmaine Bernazar, and then Alex Javier Alvarez. On the fourth, we have Napoleon Torzelino, and then on the fifth, we have Blas Palma. Last question. The null hypothesis of correlation analysis is independence of two quantitative variables or independence of two qualitative variables. The correct answer is independence of two quantitative variables. 81% of the participants were able to get the correct answer. Okay, well done, everyone. On congratulations to our top 10 winners. On rank 1, we have Charmaine Bernazar, followed by rank 2, Alex Javier Alvarez, and then Napoleon Torcelino, followed by Blas Palma. Next is Jeffrey A. Salem. On the 6th, we have Maria Teresa Nebor. On the 7th, we have Dr. Nor Fatime Alonto. And then on the 8th, we have Ambassador Sergeant Joseph Placer. 9th is Ricky R. Colima. And on the 10th place, we have Kifler Rivera. Congratulations to all of you. You'll be receiving your quiz completion certificate after our live event. It will be posted on IGP's official Facebook page. Thank you so much, everyone, for joining our live quiz competition. And at this moment, we will now move to the most awaited part of this program, the Q&A portion. You may start sending your questions. Meanwhile, let's enjoy watching this short video. Okay, let's welcome back our speaker for today, Sir John Patrick D. Serrano. You may start sending your questions now. Okay, let's give the participants a few minutes to type in their questions, Sir Patrick. Okay, we are waiting for your questions. And by the way, I would like to thank IGP for giving me the new certificate of lifetime membership today. Thank you so much, IGP team. Okay, I should say that the topic today is really very challenging for all of us. You were right, sir. We are not a statistician, and there are some words, some topic that you have discussed that are not familiar with us. But it was very interesting and very useful. Thank you so much, sir. Okay, my dear knowledge seekers, do you have any question for today's webinar? Is there any clarifications? Okay, I don't see any question at the moment. So, okay, I want to throw this question, sir. When we are doing the research, is it really, why is it that we always do statistics?
Uh, the utilization of statistics po is rooted from the method of research that we have actually. So if the nature of our study is quantitative by nature, definitely the numerical language of our research should be dependent on statistics. However, not all research papers are quantitative by nature. Could be possible that we would conduct purely qualitative by nature, and in those cases, we will not depend much on statistics because the language of qualitative research does not lie on statistics but on coding, on how we're going to look for the themes on our qualitative research. Could also be possible that our research is mixed by nature. Could be a combination of qualitative and quantitative research. Based on your question po, ma'am, the utilization of statistics is really rooted based on what is the nature of our study is in the first place. So if it is quantitative, we depend much on statistics. Otherwise, we don't.
How do we evaluate the qualitative research? What do we usually do use if we do not use statistics?
In the qualitative research po kasi, since data gathering is not numerical by nature. So, for example, in the conduct of research po kasi, there is something that we do not know, and we use research as a as a process of determining what we do not know. However, knowing things that we do not know is not limited to numerical by nature because there are things that we cannot quantify. So, for example, love. We cannot quantify love, but we can collect stories about love, and we can collate those qualitatively, and we could retell the story of love to others. So for example, the love of a mother to her children, there's no numerical value that could measure that love because love is beyond numbers. So could be possible, ma'am, that in the conduct of qualitative research would be free of this numerical endeavors that we have in statistics uh, because quantitative research researchers tell that the world is based on numbers. However, qualitative researchers tell that people love stories. People love stories that could inspire, that are not bound to numbers. That is why it's also possible for us academicians, even if that we are not, there are academicians that since even if they are not familiar with statistics, they could still have a strong foundation of research by dealing much on qualitative research by collecting those stories, reorganizing those stories, and retelling stories that are worth telling and inspiring others.
So when we say qualitative research, it's more on narrative form, right? It's just a
It's not
narrative form.
it's not only limited photo narration because qualitative could be dissected into different form, could be phenomenological by nature. When we say phenomenological, would deal with experiences and the meanings of those respondents to their to those experiences. Could also be possible ethnographic. When we say ethnographic, would deal uh, with the issues of those particular people in that particular locality because the etymological perspective of ethnographic is ethno, tao, graphia, lugar. Could be possible that grounded theory, narrative is just one of those, biographical,
Narrative
historical. It's not
and
only limited to
descriptive.
narration.
Yes, and it could be descriptive too. Okay, we have our question from John Kenneth Goyal. How can we easily determine the specific statistical treatment through our hypothesis when we want to utilize chi-square, t-square, and ANOVA?
Yes po. Thank you so much po, Sir Kenneth, to your question. To specifically identify our statistical treatment would not be an easy task. So to determine if it is a chi-square, you need to look for the assumption test for chi-square first. There are lists of assumption tests for different statistical treatment. So for example, for chi-square test, first thing first should be categorical by nature. So you determine first the level of measurement. So if the level of measurement in your data collection is ordinal or interval or ratio by nature, chi-square is not anymore one of your options because chi-square would require an assumption test that would have a level of measurement that is nominal by nature. Another thing you should look for the cell equivalence. You know that there's no easy way of determining our statistical treatment, but the only way to determine the appropriate specific statistical treatment is to go back to this of this assumption test. If the assumption test needed for this particular statistical treatment are completely complied, that's the time that you have arrived at the appropriate statistical treatment. Another, if we are there are cases ano ba comparison between or among groups. Say for example, among groups, I mean three or more groups, but it fails. One of the assumption tests is uh, the homogeneity of responses, homoscedasticity, and so on and so forth. If this list of if any or any one of these list of assumption test needed for a particular statistical treatment is not met, we are not arriving yet as a specific statistical treatment. It is appropriate po that the statistical treatment chosen should comply to all needed assumption tests. So
Okay,
to
thank you so
answer
much.
your question, po, Sir Kenneth, clearly, you better look for the list of assumption tests per statistical treatment, and you test all those assumption tests one by one.
Okay, just want to read again the first question that was flashed a while ago. Can you also use research questions in statistics, or one can use both? Can we use research questions? in stat?
Research questions. I don't think I understood the question
Yeah.
po. Can you reword the question?
Yeah. Can you also use research questions in statistics, or one can use both?
I believe that research questions, when we're talking about research questions, we're talking about research.
Yes. Well,
Yes.
yes, we're talking about research, and
As
then
I understand the question po, research questions are used in research. And to answer those research questions, if the study is quantitative by nature, we need to use statistics to help us answer those research questions. That's, I think, how
we
I
use
understood the question.
statistics as tool in answering the research questions. Am I right, sir?
Correct, correct, correct po.
Yes. Thank you so much. That was actually brilliant answers from you. Thank you so much, sir Paul, for the time that you have spent with us today and for the wonderful presentation that you had today with us here in IGP. I think we have another question here from John Kenneth. Do the researchers have the freedom to choose the level of significance? If no, how can we determine the best level of significance for our research? Can we
Okay po.
determine it?
That's a very good question, Sir Kenneth. No po, although it's not part of our content this evening, but I'll answer that. We do not have the freedom to choose our level of significance because there are level of significance that are appropriate for situations. So for example, if your study is experimental by nature, you should use 0.01. I repeat, if your research is experimental by nature, you should use 0.01 as your alpha level because there is this what we call as the standardization of procedure that we have in our experiment. We should standardize the procedure so that it would increase its external validity that after that experiment, that procedure or that treatment could be used and adapted by others, and the results would be almost the same. So 0.01, we do not have that freedom because there are appropriate levels of significance per cases. If our study is survey type by nature, 0.05 po ang ating ginagamit. And those are just few of the considerations. No po.
Thank you again, sir. Thank you again for answering all the questions of our audience. Well, that completes the Q&A part of for today. And of course, I would like to thank all the participants who actively engage in our Q&A part. Thank you so much for your questions. I hope you have gained huge understanding of today's webinar. And to our honorable speaker, words are not enough to express our gratitude for the time that you have spent with us in this session and for the knowledge that you have shared. Truly, they are valuable for our audience. You added another bulk of ideas, knowledge into our knowledge bank. Thank you so much, Sir John Patrick Serrano. Thank you, sir.
Thank you po.
Um, Thank you for gracing our event, and we hope to see you again here in IDP in our upcoming webinars. Thank you, sir.
Thank you po.
Before you, okay, thank you, Sir John Patrick D. Serrano. And thank you for gracing our event for today. Our code for today is IG for our certification code and certification process. Our code for today is IGP 16627. Our code for today, please take a screenshot of this. Our code for today is IGP 1627. Today's date is June 20, 2022, and today's program name is Prerequisites to Hypothesis Testing in Statistics. Remember that without code, no one is eligible for certificate. With code, you can claim your certificate anytime. Without an account on our website, you can visit, but you cannot do anything functional. Okay, this has been a very rewarding day because of our dynamic speaker for today. Again, I would like to express our my heartfelt gratitude to our keynote speaker for the valuable knowledge that he has shared to us. To my fellow knowledge seekers, I would like to thank all of you for attending today's session. Let me thank all of you for being so patient, active, and attentive all throughout the webinar. Hopefully, you have learned something new today that will be useful in your life. If you have learned something and we have been helpful to you, even just in a little bit, please leave a review on our page. And also don't forget to like and subscribe to our Facebook page, Facebook group, and YouTube channel. Please spread the information about IGP to your friends and to your community. Don't forget to collect your e-certificate after the session and give a check-in with IGP. You may collect it from our website or through the link mentioned below. Our website is www.eduigp.com. And remember, our code is IGP1627. To collect your e-certificate, please go to www.eduigp.com. Make sure to log in using your account, or if you are just new, please create an account, then log in. Click free webinars, choose today's webinar date and title, then get enrolled to that webinar. And once you get enrolled, enter the code for today, click the bar, get your certificate, and then your e-certificate will be auto downloaded to your device. Another thing that I would like to tell you before we go is that I would like to invite everyone to join the Institute of Global Professionals official Facebook group, because in this group you can post your achievements. I encourage everyone to please post your achievements in IGP, such as your quiz competition certificates and your webinar e-certificates. And in this group, you can also send your queries regarding our webinars and also regarding the e-certificates and other matters about IGP. The IGP CSR team and IGP's facilitating officers will be happy to help you and to assist you with all your queries, especially for the new participants. Remember that IGP cares for you. Well, that concludes our program for today. To all IGP pre-webinar participants, thank you so much for your unwavering support and for your active engagement. Remember, IGP is always here to render you our best service. To Team IGP, job well done for another successful live session. This has been a rewarding experience and a worthwhile event for all of us. We hope to see you all again in our upcoming webinar that will be tomorrow morning. All things work together for good to those who love God and to those who are called according to His purpose. Thank you so much. Stay happy, stay safe. Again, this has been your host, Maribeth from the Philippines, signing off. To God be the glory. Bye, everyone.